making a confession that I'm a narrow-minded economist, and I actually find it helpful for me. And for me, human beings are machines. And these machines basically have to solve three types of trade-offs, which I call the fundamental trade-offs. And all decisions in life, large and small, are basically governed by some mixture of these trade-offs. And these trade-offs are risk versus return, today versus tomorrow, and self versus others. So for example, the big question of how much I should save for retirement, it's of course a question about risk versus return. It's a question about today versus tomorrow. And it's also a question about self versus others, whether I want to leave something for my kids, or I expect my kids, or even society as a whole, to take care of me when I'm getting old. And I will talk about these preferences as this will be the primitives for me of basically everything. There will be preference relation over R. These are risk preferences. And if Armin basically told us that there are different risk preferences, if you talk about monetary risks and you talk about health risks, you can have risks to your reputation. There are many types of risks. But I will say that there are preference relation R, and this basically determines our risk-return trade-offs. There will be a preference relation T, which basically talk about our time preferences. And there is preference relation that I will call S, and this basically our social or distributional preferences. And because this is a summer school about social economics, I'm going to talk about this today. But the question that I'm going to ask, you can apply also to preference ordering R and to preference ordering T. And tomorrow, I'm going to talk about how combinations of these preference orderings can basically tell us other preferences. And I would actually claim that I have a definition for morality. And the definition of morality will come from this, what I call primitive or basic preference orderings. These are the preference ordering that are basically governing the most primitive decisions or the most primitive trade-offs. And tomorrow, we will talk about preference relation M. That will be some combinations. So, like in a standard micro class, we are basically saying that this symbol is the primitive of everything, and from it, we get the strict preference ordering and the indifference relation. That's basically the view. Okay? Now, I'm an economic theorist and I'm an experimental economist. Now I'm actually also moving into dealing with a little bit with data that is not experimental, definitely not data in the scale that Armin is able to digest. This is too large for me. But when I move to talk about data, I basically want to answer 4 questions. That's it. I'm talking about individual decision making. I'm not talking about games. And every data set that you'll give me, I would think about the quality of this data on how it answers these questions. And these questions are basically based one on top of the other. You don't have these questions in your notes. I hidden them from you. But I will show you. I will show you now the questions, and I will answer these questions about social preferences or distributional preferences, but it can be asked about risk preferences and other preferences as well. So here are the questions without further ado. The first question is behavior consistent with the utility maximization model? In the sense are people rational? In the sense of revealed preference conditions. So, all the data that we actually see, or most of the data that we see, or the data that we saw in Armin's talk, we talked about risk preferences. I can always raise my hand and say, look, in order to have preferences, you need to have a complete and transitive preference ordering. Do you actually know whether all of these people have a complete and transitive preference ordering? Because otherwise, to say men, for example, are less or more risk-averse than women, let's just think that men are less consistent, meaning they are less rational with women. And what you are actually interpreting as more or less risk aversion, it's actually the lack of risk preferences altogether. It's mistakes. Okay? So the first question, whenever you'll come to me with experimental data, or I'm talking about experimental, but any kind of data, I will tell you, wait, stop. We are always thinking about this data in the sense that people are maximizing some objective function, right? People are purposeful. This is what we economists mean by rationality. If I'm going to give you a set of alternatives, you have complete and transitive preferences over these alternatives, and you will be able to rank it to me from the very best to the very worst. We always take it for granted, and then we are starting to think about what actually the preference ordering is. But maybe people don't have preference ordering at all, and we need to exclude them. They just don't understand. They are incoherent, they are not purposeful. Okay, if the answer to the first question is no, people are irrational, you know, there is economics, for example, with incomplete and intransitive preferences. There is some general equilibrium with incomplete preferences, but 99% of economics, we are starting is that, you know, agents have complete and transitive preference ordering. So if the answer to the first question is negative, then I think that we are in big trouble. If the answer is not negative, then we can move to the second question. And the second question is behavior consistent with utility function with some special structural properties? Okay? Suppose that I have a data on you, and I know that you maximize a utility function. Now I can start asking myself whether this utility function is additively separable. Whenever I see additively separable utility function, you know, I think it comes from our own mind, right? Why we put additively separable utility function? Because then it's easier to write the Kuhn-Tucker conditions and to solve it, right? Because basically the trade-off between any two goods is independent of the third good. But is this assumption actually true? Are people maximizing utility function that is additively separable? I don't know. Now, we also need to, we are always thinking about expected utility. Are people expected utility maximizer or not expected utility maximizer? If you are an expected utility maximizer, then the underlying utility function that you maximize is additively separable, but not vice versa. Additive separability is different from the independence axiom. So we need to start studying the structure of the utility function. So in some sense, most of what we do, not only we assume that the utility function exists, we're also imposing the utility function, okay, without studying the structural properties of this utility function. The third question is, it maybe sound a little bit philosophic, but after Armin talks about morality, we can be philosophic, I think, about things. And I will ask, can the underlying preferences be recovered from observed choices? So suppose that I know that someone is consistent with utility maximization, and I can even, I even know a lot about the structure of the underlying utility function. It still doesn't mean that I could actually recover the underlying preferences. First, before I know that I'm estimating really the correct utility function, there is always identification problem. I'm both testing that I'm estimating the correct model, and I'm trying to back out the parameters of interest. So let's suppose that I know that you are consistent with some utility maximization, and I'm writing a model, and I'm trying to estimate the parameters. And I have an error term in the estimation, of course. What this error term is? This error term is only my error term, because you are maximizing some function. So when we are thinking about the statistical properties of this error term, normally distributed with mean 0, I'm always laughing. What do you mean? This is your error term. You should know exactly what your error term is. Okay, good. You are maximizing some function. So an extremist like myself will say that basically using parametric estimation, you can never solve this identification problem unless you actually know by structure that you pin down the underlying utility function. Even a more extremist like myself will tell you that this might be even mission impossible if you follow the Herb-Simon approach of procedural rationality. And then what can happen is that the revealed preferences might not be the true underlying preferences. If people are using procedures, let's not speak about this. This will become too philosophical. And finally, after this, I think that there is a question that Armin touched a lot. We basically want to understand the determinants of preferences. We want to understand where they are coming from. So we want to study the heterogeneity. Can the heterogeneity be explained in terms of social and economic variables? Okay, and these are the questions. Now, my claim would be, I don't want to start here that we'll go into methodology, that if I could answer these questions with market data. I could just go to the real world and collect data that can answer this question. This is, of course, superior. Right? These are data from natural decision environments and often with high stakes. So if I could solve, so the first thing that we need to ask ourselves, can we answer a question with a market-generated data? And this is what I always do when I hear about an experiment. Why did you do an experiment, right? We do experiments in physics on things that we cannot learn in the real world, right? So first thing we need to approach is just data. But you know, data from the real world is subject to many identification problems, and I would actually claim that with data from the real world, just from the structure of it, you cannot pass even the first question. Real world data doesn't provide a strong test of whether people are actually rational in economic sense. Survey data I'm not going to even to speak about. I think that there is a very serious problem. You know, survey data of basically asking me how much do I weigh, this is fine. I can go, I can find how much do I weigh. But asking me survey data questions about my risk tolerance or other things, basically asking me about these preferences, I think that there is something very problematic in this. It's almost like asking me, how do you ride your bike? I can't explain it. If you want to understand how do I ride my bike, give me a bicycle, we'll go outside, I will ride my bike, and you'll watch and we'll understand. And you know, the way that I'm explaining it to undergraduate, I'm always asking them, you know, I'm doing a survey. And I'm asking, you know, one of them, how much you like dolphins? So he thinks very hard, let's say on a scale to 1 to 10, and he tells me, you know, the typical answer is 8. I say, wow. I say, whoa, you know, you really like dolphins? He said, yes, of course, what not to like about dolphins? And then I say, now, of course, the question is not even well defined. What do you mean? You like dolphin in the sea? You like dolphins on your plate? It's not really clear. But anyway, he says 8. He says 8. Then I'm asking him, okay, interesting, how much you like sharks? So, of course, you see, there are all the effects immediately. We'll say, he asked me now dolphins. Now he asked me about sharks. I need to compare sharks in some way to dolphins. And then a typical undergraduate at Berkeley will say, I like shark 6. So I want to make sure that I understood. So I'm saying, you really like dolphins, and you really like sharks, but you like dolphins more than sharks. We reach an agreement that this is the case. And then I'm asking, you know, how much time, money, or anything in your life you gave to a dolphin? And the answer will be 0. And how much you gave to sharks? The answer will be 0 as well. So the survey reveals, you know, very large emotional response to dolphins and sharks, and actually but the truth of the matter is that this person doesn't care about dolphins or sharks, period. So we can only understand preferences from choice behavior. I don't believe that we can understand preferences from survey data. In particular, if I ask you a question about your preferences, I assume that you have a rational set of, you have rational preferences. You have preferences, basically. Okay, so that's the starting point. Yes?
Do you think that it needs to be predicted from something?
Like correlated with something. You mean correlated with something?
So maybe you put them in a certain circumstance.
Yes. So my belief about life is that if you'll check for enough correlations, you will find the one that will make you very happy or the one that will break your heart. Well, it depends. Yes, I agree. Things are correlated in the world. So should we go and check for all correlations possible? Yeah.
How well defined is the consistency question?
Ask Samuelson, ask Ozawa, ask Afriat, and they will tell you.
What I'm getting at is if I narrow my choice set, if I have a fine enough choice set, I can give anyone transitive preferences.
Okay, so that's a good, so you need to come with a choice data, like everything, that provide a strong test of the hypothesis, right? That's what you are telling me. Look, if I'll give you 3 options, they are going to be very different from each other. You will have a complete and transitive preference ordering over these 3 options. But this is not a very strong test, right? It's almost as if I want to see how good basketball player you are, and I'll ask you, the basket is here, and I'll ask you to do something from here. Then I cannot conclude how good you are, right? So you need to come with a strong test. Okay? Now, if the test is in the laboratory, you also need to be worried about its external validation. Right?
At any point that you witness what one can claim to be a violation of transitivity, you could then disclaim that it has to occur at a different point in time.
No, you are doing it in a snapshot. This is, for example, why I think Ermin talked about it as well. If you have data from the real world over time and you see changes in behavior, you can basically attribute these changes to changes in preferences, and then you have preference reversals. This is of course, will be violations of reveal preference axioms. But you can also say constraints have changed, and I didn't observe the constraints, or the person has more information. Now, if we get into this question, look, suppose you observe the two of us, and we behave differently. She bought a BMW, and I bought a Honda Civic. So a typical economist will tell you, she really likes cars, and Sachar doesn't like cars, right? This is a preference explanation. But if we'll think a little bit, we might like cars exactly the same, but she has a lot of money, and I have little money. But it might be that even if we have the same preferences and the same constraints, we have different information. She has one information about what a BMW will do to her life, and I have a different information what it will do to my life. And finally, even if we have the same preferences, the same constraints, and the same information, because the world is ambiguous, we can come with basically beliefs that are quote-unquote rational based on the information available to us. So it's also beliefs. And different people tend to put the variation on different things here. But the truth of the matter is that we have a very serious identification problem. And when we are doing things over time, more things are changing. Constraints are changing, information is changing, belief is changing. And the fact that people are choosing different things over time says very, very little. Okay, yeah?
There's people doing review preference tests on like supermarkets, candidates.
Yes.
They don't seem to.
It's a very weak test. It's not that I'm just saying it's a very weak test. Let's think about it like we thought about it in intermediate micro. Suppose I give you two budget sets. And the budget sets, there are no variations in prices, it's just changes in income. There is no way to violate, right? So this is exactly the problem in the real world. The variations in prices is small relative to the variation of income. So even if you are completely inconsistent, we cannot find it. That's exactly the problem in checking for reveal preference conditions with real world data. Moreover, there is almost a theoretical, there is a paper by Varian that shows that you really need the entire data set. And in these papers, of course, you miss some. Suppose that I'm going out of the supermarket and I buy a banana at the first grocery store. So now you have an incomplete data set about my grocery shopping. Of course, you have an incomplete data set about all my shopping, but even in the domain of grocery shopping, you don't observe all my grocery shopping, and this makes the test even weaker. Weaker to the level that Varian says that anything can be rationalized. Okay, very weak. Okay? Okay, so look, we are forced to answer these questions in experiment. We are forced. It's not that we like it. Okay, any questions? Okay. So, because it's a course about, it's a summer course about social economics, we'll talk about distributional preferences. And distributional preferences are the preferences that we believe that, they govern our opinions on a range of issues related to the redistribution of income. Examples basically include all the difficult problems in our society, government-sponsored healthcare, social security, unemployment benefits, you name it. And what are the problems here? The problems are these issues are very complex because of two things. First, when people are thinking about unemployment benefits, first they are taking a position that is basically serving their own personal interests. Right? If I think that I'm more likely to be unemployed, or I am unemployed, I will be for extending unemployment benefits. But moreover, people also might disagree on what is fair or a just outcome. So, there is no way we can basically understand public opinions of a number of important policy issues without understanding these distributional preferences. So there is some survey evidence that Democratic voters are typically assumed to be more equality focused than Republicans. And there is a lot of survey evidence coming, and these are papers that are just coming out at the AR, at the Review of Economic Studies, et cetera, et cetera. Okay, so let's use this example. And you know, these debates in America and elsewhere, or of course, these are hush debates. But let's suppose that people don't have a consistent, they are not rational over it. They don't have, you know, well-defined distributional preferences. It's very different to think about these debates if we see that people are actually rational. And the debates are because people are having different opinions about equality versus efficiency. Okay? So one of the things that we will try to do, and now I'm trying to tell you why this structure matters. The first thing that we are going to test whether people have consistent preference ordering. And then we are going to start studying, using revealed preference condition, the structure of the underlying utility function. And we will be able to, by using revealed preference conditions, to basically pin down the structure of their utility function. And this utility function will have two parameters that are distinct. One of them, what we call fair-mindedness, and the other one is what we call equality versus efficiency. Okay? And I will, once you see the utility function, it will be perfectly clear what are the two parameters. But what is basically fair-mindedness? Fair-mindedness is the weight that you put on your own income versus the income of others. So people who are fair-minded are putting equal weight on their income and the income of the other person. Equality versus efficiency is something different. Equality versus efficiency is the weight that you are putting on reducing differences in income versus increasing total income. And you know, as we know, that's where economics starts. It's usually you cannot hold this stick at both ends. And if we go back even to Harsanyi and Rawls, you know, both Harsanyi and Rawls basically promoted different theories of justice or of moral preferences. And of course, there were many debates by Harsanyi and Rawls, from Harsanyi and Rawls. We'll talk about it tomorrow. But both of them agree that you have to be fair-minded in the sense that you need to be impartial. But they, of course, disagreed about how equality should be traded off with efficiency. Okay? Okay. So what we are going to do, we basically designed the platform to answer the questions. And the way to answer the question is basically to give subjects to do experiment over budget sets. You know, the theory of revealed preference is built over budget sets. I also believe that in the world, we don't face binary decisions or discrete decisions. We always observe, you know, we actually observe budget sets. And this will become a crucial point later. So we are going, the result that I'm going to show you now is an incentivized experiment using the American Life Panel called ALP. And we will combine data from this experiment with individual demographic and economic information about the panel members. So first, from the experiment, we will try to answer the first three questions about consistency, structure, and recovering the underlying preferences. And then we'll use the data that we have to answer the fourth question. Okay, that's the nature of the exercise. So the experiment proceeds as follows. It's a representative sample of Americans. People are doing the experiments at home on their computers or on their TV if they don't have a computer. So we are not interfering. They're not coming to the laboratory. There is no face-to-face interaction or anything like this. The experimental interface basically looks like this. And what happens here is as follows. What we tell subjects, I later show you exactly how it works. Subjects can basically, let's not talk about experimental methodology, but subjects can choose any point on the line, on the budget line. They are doing it by basically moving the mouse. That's it. And by moving the mouse on the line, they are basically choosing an allocation between two accounts, X and Y. in the experiments that I will discuss today, you know that the money that you allocate to the Y account will go to you, and the money that you allocate to the X account will go to a random ALP respondent. Okay? Now, there are two differences here from standard experiments. First, standard experiments are binary or discrete. And secondly, standard experiments are not presented graphically. So there are two issues here. We can talk about them later. We have a lot of experience with this. We learned a lot. I will just say now that there is no way to present a budget set not in a graph. When I once presented it at Stanford, really early papers with this, Paul Milgrom told me, you know, these are textbook cartoons, but you should take it as a compliment, because if this is the way that we explain in Econ 1, in Principles of Economics, what is the budget set, this is how we should do experiment, because the experiment is not about understanding the trade-offs, it's by basically doing decisions that you perfectly understand the trade-offs. And there were experiments using budget sets where budget sets were given, let's say, in a table, and then you found out that many people are basically dividing equally or putting zero and everything in the rest, because it's very hard to see a budget set in a table. So you cannot fine-tune your decisions. Okay? So one of the good things about this platform that is just a budget set, and so the most important thing about it is that we now, if you think about a lot of experimental data, think about it in terms of the questions. You cannot answer the questions that I highlighted. And you know, most of empirical economics, if you open Ditton's book, standard empirical methods are about budget sets. They're not about binary decisions, okay? So basically what we can do with this type of data, we can use powerful techniques from revealed preferences to understand whether people have preferences, the structure of their preferences, and then, you know, standard techniques from demand analysis, okay? So how the experiment moves, if you can see, the scale here is from 0 to 100. And during the experiment, subjects will observe 50 lines like this. They will make 50 decisions. Eventually, we will pay for one at random as the standard random incentive mechanisms, which has its problems, but I can address it. If we have time, we'll speak about it, because you have revealed preference tests, basically. And which type of lines subjects will see? Every subject will get 50 lines drawn at random under one restriction, that at least one of the intercept is above 50. Why? Because this basically gives us such that price intersect often. Okay, this is what it means. And if you ask me, why 50? Why these lines? I will tell you, I have a theory. And in a nutshell, I have a mathematical theory and I have a statistical theory. So we can never argue whether this is, if you want to argue whether this is the right experiment or not, in terms of the decision that I gave, you'll need to go and argue with Samuelson. And this was hard even when he was alive. So this is not something that is easy to do. And you know, there are some experiments that we only did 25 decisions. There are other experiments that we did 150 decisions. It always depends. But what's the metric, basically? The metric is that the experiment has to be strong enough such that we will be able to identify the effect of the trembling hand. Okay? If your hand trembles a little bit, the trembling hand of the mouse, we will already see it in our measure of consistency. Okay, loosely speaking. The other advantage of this is a platform that you can basically study also the other preferences. You want to study risk preferences, X will be money in one account, Y will be money in another account, and after you choose between X and Y, I will flip a coin, and I will pay you only according to one of the only according to the account that was chosen. You want to do time preferences, X is going to be money today, and Y is going to be money tomorrow. So you see where it's going. These are just goods. You need to label the goods and to move on. And then basically you can actually go through a series of understanding all of these preferences by holding the experimental technique fixed. Okay? They're not new questions. It's not that I'm going to face you with one experiment to understand your risk preferences and another experiment to understand your social preferences. The experiments will be exactly the same. Yes?
Perhaps a basic question. This isn't even fair in the budget
Yes, there will be a lot of variations in prices.
Right. So I'm not sure it works for this experiment, but in general, how do you know that when you don't vary, whatever you're varying in your experiment isn't actually varying the frame in which subjects are viewing the choice?
Okay, so there are two questions. The first answer is external validation. If I can find that this has external validations or outcomes in the real world, then it's not the framing, and we of course validated it. And secondly, if it's the frame within the experiment, then you will have violations of revealed preferences. Why? If your decision rule doesn't depend only on the slope, done.
But, right, so but maybe this is the philosophical part. Why would we call that a violation of revealed preference? It's just that the frame, in that frame they have these preferences,
Yes.
in that frame they have another set of
Yeah. So the question that I'm asking is the following question. When I'm asking the question of revealed preferences, I'm asking, is there a utility function with over xy? And it's true. You are basically saying maybe there isn't here, but I can always find u, xy, and omega, which omega can be. And this is true. So people that might have violations of revealed preferences here, they might have what I would say a less parsimonious utility function. And this is true. You can always, basically, I can always find you a set of omegas that will rationalize everything. Luckily, most people are like this. That's exactly the point. Most people are super rational in a way that it's, I find it.
In the context of your experiment.
But then I'm going back to external validation, and for example,
So you're going to show us that.
I know I'm not going to. I'm going to show you, for example. I'm not going. Look, we spend a lot of time in this, and part of the. Let me just say about the external validation. There is one thing to show external validation in the sense that your risk aversion in the laboratory are correlated with insurance. This is not what we are doing. We are actually showing that people that are, let's say, more consistent, more rational, accumulates more wealth, they have better economic outcomes in general, large outcomes in the real world. And because Ermin basically talked about it, in a horse race, whatever this means, we win the big five, the IQ and everything else. Okay, by far. It's not that they're not important, but we win by far. Okay. But this is, let's, yeah. Okay, so, I don't know, I pressed a few things. So this is the case, okay? And this is the case. I'm only going to talk about experiments like this. We are also doing experiments with three-dimensional budget lines. Why three-dimensional budget lines are important? Because, for example, in order it will be three-dimensional. There are three goods. Why three-dimensionals are important? Because without three goods, you cannot test, for example, for additive separability in a meaningful way. Okay? So we can do this as well. Questions? So basically, like I say, you seem puzzled. It's a budget line. That's it. If economists see a budget line and seem disturbed by this, it says something. So here it is. You see, here I'm moving the mouse. Oh, I don't know what to do. I'll press enter. I'll see. Oh my goodness, it's a different price. What should I do? I should move like this. I'll do another one. You see where it's going. Okay. So. Why are you sorry? You're not sorry. Okay.
Why can't you let them choose the material?
We allowed this in early experiments, and no one did it. And people, yes, and people spend enormous amount of time to actually getting to the frontier. So we removed this. It just made it much slower. Okay, and now let me say something about this data. This data. Each person is making 50 decisions. Each person faces a different set of questions. If you take averages over everything, you'll fall exactly in the literature. You know, the standard things that we are talking about. But there will be huge heterogeneity. Almost no person is going to be like another person. Every person will have a different rationality score. It's really on a continuous variable. And each person will have different preferences. And extreme preferences, like people that are Rawlsians or utilitarians, you'll almost never see. Okay? So it's very, very heterogeneous. And partly, again, in response to Armin's talk, most of what is come from these experiments is that personal characteristics cannot explain the variation. There is still, you have a lot of data, so you'll always find significant difference in means between gender and ethnicity and all of this. But there is much more variations within standard sociodemographic than across sociodemographics. Okay? Okay. So let's just fix a little bit the notations here. Instead of calling an allocation from the budget line X and Y, we'll call it pi S and pi O. Pi is the money for self, and pi O is the money for other. And we'll normalize prices to 1, so pi S plus PS pi S plus pi O, PO pi O is equal to 1. And now I want to basically distinguish what do I call fair-mindedness, and what do I call preferences weighted towards equality, and what do I call preferences weighted towards efficiency. So I will call someone fair-minded if basically first he has indifference curves, meaning he is rational, but also the indifference curves are symmetric around the 45-degree line, meaning that if you gave me this budget line, and then you give me this budget line, that I'm basically, it's the mirror image. So I replace prices, I replace the allocations. If I take PS and I move it to be PO, I will take pi S and I will move it to pi O. This means that basically self is treating self and others symmetrically. This will be someone who is fair-minded. What about equality versus efficiency? Equality versus efficiency is something else. If your choices are such that the fraction of expenditure, remember, income is normalized to 1. So this is the fraction of expenditures that you do, the budget that you spend on money for self is basically when the price ratio, the price of redistribution increases, if it's decrease, it indicates preferences weighted towards efficiency. Why? Because as it's more expensive to keep, you basically spend less on keeping. Okay? And vice versa, when you are increasing this fraction, when the price of redistribution increases, these are basically preferences weighted towards equality. And what do we have exactly in the middle? Always equal expenditures on self and other. This is going to be basically a Cobb-Douglas utility function. Okay? Because if you have a Cobb-Douglas, if you have this utility function, and the utility function is Cobb-Douglas with equal weights, then basically, or never mind, leave the equal weights. If it's equal weights, you are also fair-minded. But if you have if your distributional preferences can be represented by a Cobb-Douglas function, you are exactly the threshold between equality and efficiency. Because you'll always spend exactly the same fractions on self and other. Okay? Okay, so now let me just talk about everything that is wrong in what we are doing. So the preferences that you see here, these are basically the working horse in this literature. These are what is called the Charnes-Rabin preferences. And as you can see, these are preferences over pi O and pi S. These are the distributional preferences. And if you look at Charnes and Rabin's paper, the QJE from 2002, called Understanding Social Preferences with Simple Tests, basically this is what they do. How this in different, so first, in this entire paper and all other papers, they assume that indifference curves exist, and they assume that indifference curves have the structure coming from this utility function. How these indifference curves look like? Leave all the indicator function. This indifference curve is piecewise linear from the two sides of the 45-degree line. It looks like this. Okay? So there is a lot of structure here. Okay? Now, what's the debates in the literature? The debates in the literature, so let me first basically say what kind of preferences it spans. So depending on the parameter, you can have competitive preferences, selfish preferences, and the most important thing is difference aversion preferences, a la Fair-Schmidt, or preferences to maximize social welfare. What's the difference? When preferences are preferences to maximize some aggregate of the two payoffs, this part of the indifference curve is downward sloping. When you move to Fair-Schmidt preferences, this part of the indifference curve is upward sloping. So in Charnes and Rabin, what they did, if you'll think about it in this, they have many, 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 many binary or discrete choices that basically are designed to mainly to understand whether this part of the indifference curves is upward sloping or downward sloping. But everything is based on the fact that you assume that people have indifference curves, and these are indifference curves. Okay? Now, if you believe, like me, that the world is basically based on budget set, or at least on convex sets, this debate, whether the indifference curve here is downward sloping or upward sloping, is like this episode in Seinfeld. It's a show about nothing. They proposed to NBC. And Samuelson already told us this. Samuelson told us that even if the utility function is non-well behaved, it's in the limbo for us. I couldn't care less about it, right? Because choices will never be made in parts of the indifference curve that is not well behaved. So basically, there is no way to distinguish in indifference aversion and Rawlsianism. Okay? And this is why you need to start having these binary options in order to get these cuckoo preferences. It's really a debate mostly about nothing. So here is exactly the problem by actually writing a model. If we think about the history of this literature, Fair and Schmidt came with a model which is very nice, it's very provocative. But then, we fall in love in our own models. We forget that this is a Harry Potter. And then we test it in some kind of sense and start debating whether it's the right model or the wrong model. So this model cannot be right or wrong because it cannot be tested. Okay? You really need something very extreme in order to test it. Okay? Questions? Okay. So we are going to use a more standard model of distributional preferences, and we are going to use it only after we get from revealed preference test. It will be quite hard to pin this down exactly. In the case of two people, I can pin it down exactly. So people that will be sufficiently consistent with revealed preference conditions, not only that they are maximizing utility function, that's the utility function that they are maximizing. When I'm moving to three people, this will be a bit harder. Okay? I can get close by, but I cannot actually get to this. Okay? How do you do this? You move from the general axiom of revealed preferences to the homothetic axiom of revealed preferences, and you continue. Okay? What is this utility function? This is the standard constant elasticity of substitution utility function that we know from production, from open variance book. This will be there. It's nothing new. In the context of distributional preferences, we have two parameters, alpha and rho. Alpha, of course, is the weight that you put on your own payoffs. And so this is a measure of fair-mindedness. And what is rho? Rho is the curvature of the indifference curves. And the curvature of the indifference curves basically captures your equality versus efficiency. Okay? Questions? So what are we going to do? We are going to take a large sample of Americans. The first thing that we are going to do, we are going to see whether they are consistent enough with revealed preference conditions in this setup to even think about whether they have distributional preferences. After they have distributional preferences, we will, and this is the right function, we are going to estimate these parameters alpha and rho. And later on, we are going to see if at all or which one predicts voting behavior, political behavior. Why? You can think about Sachar. Sachar is a Democrat because of the rho. I care more about equality than efficiency. Or you can actually think about Sachar is a Democrat because he's poor and selfish. So it's a self-serving. Of course, the example works much better for Republicans, but I just want to be moral, so I gave it on Democrats. Yes?
So the Turnus and Raven, or the transparent utility function, makes a big deal of the preferences are different depending on whether pi s is bigger than pi 0 or pi 0 is bigger than ps. But that doesn't come up in the CES.
Yeah. So let me say, so we are going to rule it out completely.
Okay.
So how can I rule it out completely? So basically, in the world of the behavioral economist, there is basically a reference point here. Right? The reference point is whether I'm more, okay. So in general, it really doesn't matter in which domain we are speaking about. So let's think about the domain of choice under risk. Just like take a completely different domain. Expected utility is something that will generate smooth preferences like this. If you go and you take, so I'm talking about a different model on purpose. Take, for example, Gould 9091 loss disappointment aversion model. There is a reference point, and the reference point is the 45-degree line again, which is basically what I could get for sure here, right? And how Gould preferences looks like. The curvature of the indifference curve is exactly the same because this is coming from risk aversion. But in the Gould preferences, that there is going to be a kink at the 45-degree line. And the kink will basically determine your disappointment aversion. It's a reference point, and the curvature, your risk aversion. And this is exactly the case here, right? So what's the difference between, in our setting, what's the difference between having smooth preferences and having a kink? Because prices are drawn from a continuous distribution, you will never, if the preferences are smooth, you should never see heaping of observations at any point. Heaping of observation. You made 50 choices. There will never be a point that you chose for multiple prices, right? However, if you have a kink or you have preferences like this, you will see a lot of heaping. So let's take this model and assume that the preferences are not linear. So you will see a lot of observations on the 45-degree line. So this is another, I think, something about our experiment. I can tell you if this reference point actually exists or not, because it will stare at me. And this is when we submitted the first paper, I have to tell this, so we submitted this first paper, Vince Crawford, I always have to give a credit to him. Vince Crawford basically saw just scatter plot, just pictures. And he said, you know, you took the paper to a completely wrong direction, gave us what is called the reject and resubmit. This is a new innovation in economics to make the refereeing process even more broken. But he said, I never saw something like this. This is like an economic fingerprint. And this is exactly what he meant. We are always talking about reference points, and we try to create reference point by manipulating subjects into groups. Here, the reference point, the data are so rich that basically if the reference point is a kink in the indifference curve, this is what it means. And if you have kinky indifference curves, I will be able to see it in a naked eye. I don't need any fancy econometrics to back it out.
And you're basically saying you don't.
We don't. Look, for some people you'll see. So
That's where the heterogeneity would come in.
this was, some people you'll see. Some people you'll see. But by the way, so this is a good discussion. So in the domain of decisions under risk, by and large, I would say that people are finding that 30% of the people are consistent with expected utility and the 70% other have kinks. But it assumes that everyone have preferences. We find among the people that have preferences exactly the reversed. 70% of the people are very consistent with expected utility, and only 30% have kinks. And some of them have very strong kinks. These are very kinky people. But you know, when you give a very large choice set, and you actually see that these kinks disappear. Large choices.
For that 30%.
Not for these 30%.
Okay, but
no.
just to be clear, let's make sure I understood what you're saying. You give a lot of choices to a lot of people.
That's right.
There are some people, 30%,
Yeah.
who are consistently kinky.
Yes, they have kinking. But they're consistently kinking. They are kinky in a consistent way. This is fine.
That's
Yeah.
exactly what I was thinking.
Absolutely.
Yeah.
Absolutely. 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 By the way, you know that if you have, so it goes back to your first question, if you have the kind of Kosegi, now not only that we have kinks, But according to Kozegi-Rabin, kinks, or your reference point, depend actually on the choice set. So, so this will cause this. This will cause violations, and you really need to move. But this is a big, talking about what we talked in the beginning, dynamic reference dependence model is a big mixture of constraints and preferences. And you actually say preferences depends on constraints. Like we don't have identification problem that is hard enough. You make it even harder. Okay? Okay. Well, yeah. Then never mind. I won't be able to speak about anything, but there is nothing new here. I'm always too optimistic. Okay, so we are here. That I talked about. So here, for example, remember, I'm estimating a family of utility functions. So all of these functions that you see here, these are fair-minded preferences. These are fair-minded preferences, meaning in the CES, alpha is equal to 1/2. But you can see the extreme. You will get the Rawlsian preferences where rho is going to infinity. These people care deeply about inequality. And they will always choose 45-degree line. On the other end of the extreme, when rho approaches 1, you're going to the utilitarian preferences. These people are, of course, fair ex ante, but they will create very, quote-unquote, unfair allocation exposed. And finally, when rho approaches 0, rho cannot be 0, you are approaching the Cobb-Douglas preferences, which are, of course, in terms of social choice, has a lot of appeal, because it's really a nice compromise between equality and efficiency. It's exactly in the middle. Okay. So just that you'll see how this works, what you see here, how the function works, what you see here is the log of the price ratio, and I'm fixing, these are fair-minded people, I'm fixing alpha to be 0.5, and I'm showing you the relative demands. So what you have here is pi s divided by pi s plus pi o, the fraction of demand that you keep to yourself. So what will happen if you are a Rawlsian? If you are a Rawlsian, it will basically be a straight line, right, at 0.5. If you are a utilitarian, it will be a step function like this. And here you can see that the more you care about efficiency relative to equality, you are more sensitive to the price changes. This is basically what it means. Okay? Now let's take these 4 preferences, basically rho equal to -0.2, -0.5, 0, and 0.5. And let's change, make somebody, these people are Mama Teresa, they are fair-minded. Let's make them a little bit selfish. So let's increase alpha to 0.5, and you'll see where the lines are going. You see, it's basically a shift. If you fix rho and you change alpha, in the space of indifference curves, it will be like pushing all the indifference curves towards the pi s axis. And this is someone who is very selfish. Alpha is equal 0.9. So you see, so what will happen, he will not give almost nothing, and then all of a sudden, he might face a budget line that at most he can keep for himself is $10, and he can give the other person $100, and he will start being very altruistic. Okay? Questions? So this is trivial micro. There is absolutely nothing new. It is shameful that we are spending an hour on this. And we estimate it. There are issues, of course, but estimating many observation on a constraint, blah, blah, blah. You need to do Tobit. We estimate this. Okay, this is one of the most beautiful theorems in economics. It's called Afriat theorem, but actually this statement of the theorem is taken from Varia 1982 paper. The story about Sidney Afriat was that Sidney Afriat was giving take it or leave it proposals to the journals. This is the paper. I will fix typos, but that's it. That's the paper. I thought hard about it, and this is before the internet that we put working papers on the website. So basically, it was either in a journal or in your drawers forever. But Sidney was hardcore, and he wrote a paper. This is how the paper should be written. I'm not going to make these changes. This is a take it or leave it offer, my friend, the editor. Many editors, they don't like take it or leave it offers. They are used that this relationship is actually quite reversed. So Sidney had a lot of results that he didn't publish, and also the ones that he published, he wasn't the greatest writer. So basically, in 1982, Hal Varian took many of Sidney's results and translated them to human beings. And the paper was published in Econometrica for all the right reasons. You know, this was a result that no one could read, basically. So this is basically the Afria theorem restated by Varian. And it's a beautiful theorem. It basically says the data satisfy the general axiom of revealed preferences, not the strong, the generalized. Let's not get into what the differences are, but this is the twist here. There exists a utility function that rationalizes the data, and there exists a well-behaved utility function that rationalizes the data. Now, the equivalence of the first and second condition, this is the strength of revealed preference test. And the equivalence of the second and the third basically says that if there is a utility function that rationalizes the data, the utility function can be chosen to be well-behaved. Why? Because decisions are not made in parts of the indifference curve that are not well-behaved. In the case of two goods, with what is called budget balancedness, that it's always you're always on the budget constraint, together with the homothetic axiom of revealed preferences, we can basically pin down that you maximize a function that is coming from the CES family, okay, to make a long story short. When it's moving to 3 people, this is more difficult, okay? We can't really pin it down. But another good thing, we know how far we are from the utility, from estimating the right utility function. Now, what's the problem in this theorem? The problem in this theorem that this is a 0-1 test. Either you are rational or you are not. And we want to develop a measure of how far you are from rationality. There are many, many measures. It's a wonderful question in applied mathematics because the question is basically you have a set of linear inequalities. These are the budget sets. And you have a set of data. And the data doesn't basically satisfy all the inequalities. So how you can basically measure the difference between the data and the inequalities. You can relax inequalities, you can throw data points. There are many ways to basically come with a measure. The measure that we are going to use, yes?
Given the third point of the theorem, how can you identify the kinks in utility function in the indifference curve?
Okay, so yes, you know, so any function can be approximated, you know, sufficiently well by a continuous function. So if you don't have infinite data set, I can always approximate it. This is basically a gap. What I'm saying that you can actually see this in the data. You can actually see it from the data. I'll go later and I'll show scatter plot, so you will see exactly how I can see it. However, I will be able to approximate it with a continuous function. Okay, so I want to explain to you the numbers that I'm going to show you about how far you are from economic rationality. So I want you to look at this very simple picture with only 2 decisions. And here you can see immediately that there is a violation of the weak axiom of revealed preferences, and there is no utility function that these 2 choices maximize. Why? Because according to your choice on this budget line, X is strictly preferred to Y, and according to your choice on this budget line, Y is strictly preferred to X. Make up your mind. There is a contradiction here. Okay? So how can I remove the violation, quote unquote? I can remove the violation by actually shifting the budget line on which Y was chosen such that it will move right under X. If I do this, and of course shift the choice, then there is no longer a violation. But what did I do by shifting budget lines down? I'm throwing money, right? This is the cost of the violation. So to remove this violation, I can either shift this budget line or that budget line. The numbers that I'm going to show today are the shifting, the minimal perturbation like this needed in order to remove the violation. So basically, the score of this person will be A over B. It's less than 1. If you have no violations, it will be 1. The difference between 1 and A over B can be interpreted as the amount of money that this person is wasting by not having consistent preferences. This is basically the cost of irrationality. It has nothing to do with what the preferences actually are. Okay? Questions? We can use many other measures. We'll use this. Okay? Let's start with this. Okay, I will show you later distributions. Let me just say to you that this ALP sample, that is thousands of Americans, the average is 0.862. And we see, of course, significant but small differences. For example, subject without college degree, their CCI score on average is 2.6 percentage points less than subjects with college degree. Now, I'm not going to get into this, but let me just say, I'll get to it maybe later, but these are very high scores, which was me were very comforting, because this is a complicated experiment. It means that if you give the American public these questions about taxation, about redistribution, in a very, I would say, clear way, represented in a very clear way, they know how to solve these trade-offs. And even more importantly, it's not that only the elite can solve these trade-offs, also people that are uneducated. Okay? So,
I don't know what you're claiming here, because this is.
First, yet I didn't claim anything. I just said,
It is an American
no, so the debates are, in some sense, what I find comforting is the debate are done by rational individuals. Suppose, for example, that the poor, you know,
Oh, right, okay.
so we don't need to take them into account.
Something different.
Okay.
In that sense, you're saying that people can understand the trade-off.
You understand the trade-offs. And we need, we, the elite,
But this is obviously not the full trade-off. There's so much. Fine.
Okay.
Okay, good.
fine, absolutely. Okay, so, you know, if we do this, we can have different thresholds for the CCI to think about you, whether we want to include you and, you know, estimate your preferences or not, but most people are very consistent. Let me just tell you this, that if you take a computer and you really introduce a trembling hand, the CCI will be 0.95. So let's say if you are not a pedantic prick here, you will fall. You will fall from 1. You really need to be very, very careful here. Okay? Okay. So now let's just cut the data. And I want to cut the data in the following way. We'll just do statistical, you know, standard statistical test. I'm going to distinguish people that are fair-minded, intermediate, and selfish. People that are fair-minded are people that cannot basically reject the hypothesis that alpha is equal to 1/2. People that are selfish, I cannot reject the hypothesis that alpha is 1. And basically, people that are intermediate are in the middle. Remember that I'm estimating the right utility function. So actually, the errors are very, very tight here. Okay? Because you can tell me, maybe you classified someone as selfish because he has a very large standard error. Standard errors are not large here. Because this is my mistakes, basically, and a little bit their mistakes, if the CCI is not 1. The other one is basically someone who is equality focused, meaning rho is larger than 0. Rho smaller than 0. Efficiency focused, rho significantly larger than 0. And intermediate, we cannot reject the hypothesis that rho is 0. And what I think that you can say is basically what is interesting is the heterogeneity here. Okay, and we see basically people are almost everywhere. Let's skip this. We didn't talk about it. Okay, let's start with fair-mindedness. So what you see here, these are basically socio-demographic and the alpha estimates. So you see here the points here. These are mean, 95 confidence interval around the group mean, and more importantly, the 25th percentile and 75th percentile. Okay, so you can see the heterogeneity across socio-demographic and within socio-demographics. Something that stands out immediately are basically people that have less than high school education. Remember, low alphas is really more fair-minded. And these people just stand out, that they are more fair-minded and there is less heterogeneity in this subgroup. But the other subgroups you can just see. I can tell you about all of the significant differences here, but as you can see, there are very, very large variations in the distribution. Two things stands out, is people that less than high school education, and that basically non-Hispanic whites have a very large range of fair-mindedness, but the mean is that we are much less fair-minded than any other ethnic group in America. Okay. Now, what about, now, remember the distribution of the rows has a very long left tail because it goes to minus infinity. So I'm going to look at the median estimates. These are the median estimates of rho. But what you see here as well, I can start talking about differences across sociodemographics. And interestingly, again, people less than high school education, the distribution is much more compressed. And these people are actually care more than others about efficiency. And if you think about it, in terms of where they stand in society, they should actually care about equality, right? Because they are below. Okay, so now let's take all of this.
Except the unemployed, what about, you talked about the unemployed guys? Unemployed sounds seems to be very high. So that's, this is the one.
Employed, unemployed, yes.
It was a lot like the,
That's right.
yeah.
That's right. So now let's just look at a very simple regression, and let's see what can predict voting behavior. So in some sense, I wanted to find out that people that vote for the Republicans are not fair-minded, but no. The alpha cannot predict voting behavior, but what can predict voting behavior after including state fixed effects, which is important, of course, in the United States. So there are, here I'm presenting 3 specifications. These are OLS regressions of the likelihood to voting for Obama in 2012. And the important independent variables can be either the row itself, your estimate row, the decile of row, and whether your row is larger than 0. The point estimate is larger than 0 means that you have preferences towards efficiency. And let's look at columns 4, 5, and 6. And you can see that all of this is significant and negative, meaning the more you care about efficiency, the less likely you were to vote for Obama, meaning you care more about equality. And this, we have a variety of demographic controls and the state of residence fixed effects. Okay, so the point is, and there are many other things that, I don't want to show you that it's correlated with volunteering behavior and all of this. This is, of course, correlated. People that are more fair-minded, they report that they volunteer more and etc., donate their cars to public radios and all of these things. Questions? Okay.
Do you know anything on the correlation of the...
We know.
The CCEI?
Yes, we know.
Something to...
Yeah, no. Okay, and we get exactly the same result when we are basically reporting whether you are a Democrat or not. Okay? Okay, so let me think about, I have 15 minutes, right? That's the time that we have. So let me actually skip to another part of the talk, then if we have time, we'll return to this. Let me skip to another part of the talk. So go here. You can go, I don't know which page it is, but go here. Found it? It's somewhere there in the middle. Never mind, there is nothing to look. Okay, so, how to put it? We are very interested in the distributional preferences of the elite. And what we mean here basically are the distributional preferences of future presidents. So these are experiments that we did at Yale Law School. And let me just, to fix ideas about what we are talking about, this population is extremely important for the following reasons. All 9 sitting Supreme Court justices come from basically either Harvard or Yale. 2 of the past 3 presidents are also graduates of Harvard or Yale Law School. In general, in the last century, half of the presidents came from Harvard, Yale, and Princeton. 52% of Congress are from Ivy League universities. So basically, these people are people that will have enormous impact on private and public orderings in the United States. So while we really do care about the social preferences of everyone, in particular, we care about the social preferences of these people. So we are studying them systematically. The problem in studying them systematically is that you can do the experiments once every 3 years. Because after doing the experiment, Matt did one of these experiments, after doing these experiments, you basically need to give a lecture. They actually want to learn what is going on. And then you need to wait for the entire student body to be replaced. So we did it every 3 years in April, getting them into the lab. Then there is a lecture, a big debate, and people go, they leave Yale Law School, and then we start again. Okay?
You don't know the effects on their preferences in the future after that you perform the experiment.
I don't take myself so seriously. I can hardly affect the preferences of my kids, it seems to be. Okay, so I will do the following comparisons. What you see here, now I'm going back to the CCI. So now you see CDFs, and I'm going to go through CDFs, and you're going to see 3 populations. Once the blue lines are the Yale Law School students. The orange line, these are what we call an intermediate elite. These are UC Berkeley undergraduates. And the green are basically people from the ALP, but at the age range of the Yale Law School students and Berkeley undergraduates. Of course, the Yale Law School students are a bit older. Okay? So the first thing that you can see here are the results in terms of the CCI. And you can basically see these are the CDF of the American Life Panel. And you can see we have, in the American Life Panel, we have very few people that are actually at 1. And you see the distribution of these CCI scores. And you can definitely see that the Berkeley undergraduates are much more rational here, and the Yale Law School students are even more rational. Actually, the Yale Law School students, we did experiments with them also on decisions under risk and others. They are our most rational group. The only people that match with them are fighter pilots in several air force in the world. These people that know how to solve trade-offs. Otherwise, you just... Okay, so here you see this. Now, you can tell me maybe that, and of course you will be correct, that economic rationality is endogenous. This is actually a big deal because, you know, maybe I don't know what to do, so I'm going to adapt a simple decision rule and I'm going to look rational. In particular, all selfish people are going to look rational. So we can also exclude the selfish subjects here. And you can see if you include the selfish subject, people are more rational, but you still see the gaps. Okay, so this is for the non-selfish subjects. Okay, so now what about the fair-mindedness? And here you can see a big difference. Still, remember, these are Berkeley undergraduates. This is a bizarrely place, how it's called. These people are considerably fair-minded. But you see that both the elite and the intermediate elite are much less fair-minded than the population. And of course, you can also see that there are almost no people that we estimate their parameters alpha less than 0.5. And if we did it, it's basically because of trembling hands, that they went to the other side on lines that the slope was close to -1. Yes? Yes. Yeah. Yeah. So basically, you know, our future leaders, they are less fair-minded, they are more selfish. But this is, I find, even more puzzling. They care much more about efficiency. So the Berkeley undergraduate care more, remember, moves to the right, they care more about efficiency. And you see that Yale Law School, where 90% of the students at Yale Law School are basically identifying themselves as Democrats. So in some sense, this explains a lot to me about the persistence of inequality. By the way, the vast majority are Democrats, but the Republicans among the Yale Law School students, they care even more about efficiency.
They diverge from the other Republicans.
Yes, they diverge, and from the, yes. Everyone, so, yes, the future Republicans leaders care more about efficiency than the Republicans. Yes, exactly. That's the issue here. And I think that, you know, there was actually, it's very interesting to see. Armin talked about science. You know, for us, the social scientists, science is like, you know, we want to publish in science to look like the hard scientist. And science actually understood at a certain point of time that they don't attract enough papers from social science. And they're really trying to attract papers from the social sciences. So 2 weeks ago or 3 weeks ago, there was actually a section in Science about inequality. Most of it's actually invited. It's not even a paper. There are these invited views. Emmanuel Saez, Piketty, Ditton, they all wrote about inequality. It's a big thing, of course. But here is another explanation why inequality is so persistent, that the electorals are actually care more about efficiency than the people that we are actually sending to Washington. Okay? Yes. So, by the way, let me say this. These things kind of took over my life, and I want to, these programs are publicly available. We make them public. We cannot provide customer support, okay? Let me put it this way, because I wrote these programs when I was still a student, and now I forgot all my C++, and I didn't leave the documentation. So every time I need to make any change, of course, I make the change, and then I destroy half of the program. So don't expect help from me, but I can send you the codes. Okay? So I think that I'm going to leave the other part that we skipped. Maybe we'll have time tomorrow, maybe not. I will just tell you what it is about. It's about, of course, a question that we can never answer. And I'll go back to this. It's really a question that we can never answer. But I wanted to provoke you. Let me just give you the title and then provoke you. So the question is, how did the Great Recession impact distributional preferences? Of course, this cannot be answered. The most that I can ask is how distributional preferences changed during the Great Recession, because many other things happened, many other social shifts. We fought 2 wars. These are Berkeley undergraduates. The football team did catastrophically. There were many things. So of course, this I cannot do. I cannot answer this question. But in some respect, actually doing this, and we did it. It's not that we predicted the recession. Don't think that we. But thinking about how preferences change in a population that is held very constant. So we have a lot of survey data on UC Berkeley undergraduates, and when I saw there is almost no change, not in ethnic distribution over the years. I came to the admission office and I said, wow, look at this. This is amazing, don't you think? And then they said, this is our job. We hold it constant. So they looked at me like I'm delusional or something. So these people are doing a good job. They are really holding it very constant. So in some sense, there is not some change in the sample. Of course, there can be change in the sample that poorer people are coming into the experiment and so on and so forth. But basically, we have a population that is pretty constant over the years. But what's important in terms of their exposure to economic shocks, we know this from few recessions. Graduating from college in a recession is devastating for your future career. We have data from Canada. It's not only that it will affect the probability that you'll find a job when you are out of college and the salary, it actually will have an impact throughout your entire life. If you graduate into a weak job market, this is not good. Go to graduate school. Okay? This is probably why you are here. We can go over it. We can go over it a little bit in more details. We can go over it in more details tomorrow if we have time, but it is what it is, and you'll see large effects both on fair-mindedness and on equity efficiency, given the change in between 2004, let's say, pre-recession to after recession. So I want to take the last 4 minutes that I have. I promised Sanjeev that I'll end on time, and he's probably behind the door, just to verify whether I'm keeping my promise. I want to talk about, because we mentioned IQ and other things. So, I am not a big fan of IQ at all, but we were under a lot of pressure of measuring IQ as well. So we had no choice, and we started measuring IQ, which may be a good thing, just to see if these are correlated or not. And I guess that the best story that I have on this is that in our attempt to understand the preferences of the elite, we continued with other elites in other countries. So the elite in Tanzania, for example, are coming from the University of Dar es Salaam. The president, the prime minister, his predecessor, the minister of treasury, and everyone, they will be graduated from the University of Dar es Salaam, all of them. So we wanted to compare the economic rationality of students in the University of Dar es Salaam and students in elite universities in the United States, by the way, across all of these domains, wherever it is, risk, time, and social preferences. And we also did IQ tests with them. And the IQ tests that we did, I know absolutely nothing about IQ tests. The debates there, if you think that economists are debating, wait the debates and the IQ tests. But the people that I talked told me this is the standard IQ test that you should do. I find it all equally ridiculous, so I couldn't make any decision between them, but we did what we were told to do. Sometimes this is the best strategy, just do as you're told. So if you compare IQ test of students at the University of Dar es Salaam to, let's say, students at Berkeley, the top 10 percentile IQ scores in Dar es Salaam are the bottom 10 percentile at Berkeley. There's a big, big difference. And if you extrapolate, I don't know, if you think seriously about IQ, you would say, you know what? Maybe the World Bank should not actually let the Tanzanian government actually decide what to do with the money. Even, there is the issue of corruption, but let's leave it aside. Because, these people, if you really take IQ tests seriously, this is very... However, when you can compare economic rationality in the different domains, the differences are very small. There are differences. Now, of course, Berkeley undergraduate and undergraduate in the University of Dar es Salaam are very different people, but they represent the same slice in society, in the respective society. And I presented these results in Tanzania, and a minister told me, I'm an engineer. I don't know why it was important, but he said, I'm an engineer. Then he said, I don't know minister to what, by the way, but a minister. And then he said, I have no clue what IQ tests measure. This I completely agree. But then he said, but I know what your tests measure. And this I wanted to hear, of course. And he said, your tests, like it's mine, it's not mine, it's ours, it's economists. Your tests measure the ability to make trade-offs. And then he said, if you grew up in Dar es Salaam, my friend, you would know how to solve trade-offs. Otherwise, you would have been dead. So, it's not the rationality of the poor, all of this Eldar Shafir work and others, because these people are not, even though students at the University of Dar es Salaam, most of them don't have running water, and they are walking to school very large distances, and they all work, and they report to us in surveys that they are often hungry. But they will not be considered by development economists under any standard as poor. These are not people that are living from $1 a day in PPP terms. These are not poor people. Their IQ, what we measure from IQ about their ability, or if you think that IQ is correlated with some type of economic rationality, you get very, very different results. Okay? So, this test specifically, it's called Raven's matrices. Yeah, I agree completely. This is one of the problems. Look, first, most of these tests are multiple choice tests. Where I grew up, I never saw a multiple choice test. So the first time I saw a multiple choice test, I said to myself, what is this? Are you trying to confuse me? Are you trying to help me? Of course, all of the above, right? And I basically ignored it. I completely ignored it. This was just not in the Israeli education system, multiple choice tests. Then I came to do a GRE. This was, multiple choice test? I have no clue. It was the first multiple choice test I took in my life. So what's the purpose of all of this? So I basically started by studying, by actually not looking even on the answers, just, completely ignoring them. And of course there is something like this here. Of course, but this is part of the problem of IQ tests. They are subject to cultural differences. And this is apparently less. Okay. Now, these experiments, we also now have them on tablets and on mobile phones, so people are just doing the experiments for the course of the week. And because there is an issue that you are fully concentrated in this. And people are doing it on mobile phones and others, and we also went into the wild, so we are running pilot experiments in places. We started doing it by computers, but research assistant basically reported to me that they had to put something on the keyboard because it was just too exciting. The keyboard, you only need to use the mouse. So even people that are never basically saw a tablet or never worked on a laptop before, they exhibit very high level of rationality. Of course, you need to explain to them the instructions more, but once you explain the trade-offs, they understand the trade-offs. Okay, we'll continue tomorrow, and if we have time, we'll go to this. Yeah.